Welcome to our webinar, Design for Manufacturability, Unlock the True Benefits. I'm Carolyn Lowell, OrthoWorld's Chief Content Officer, and presenting our topic today is industry R&D veteran Dale Tempko. Throughout his career, Dale realized that design for manufacturability, or DFM, extended well beyond collaboration with manufacturing engineers. To ensure that products are developed in alignment with organizational goals, a DFX philosophy really should be leveraged. This approach allows you to better manage the myriad of considerations that are often overlooked in the design process. The goal of this webinar today is to share with you the more modern DFX approach and show you how to implement it in order to define successful and profitable products. Before we get into our presentation, I want to introduce our sponsor, our speaker, and share some housekeeping items. So a few words about our sponsor. As one of orthopedics' largest contract manufacturers, Tecomet understands that DFM is really a critical component in the OEM and supplier partnership. Tecomet specializes in forged, cast, and machined orthopedic implants, precision surgical instruments, sterilization cases trays, and photochemical etched products. The company offers additional project specialization through its innovative product development, including Tecomet Standard Products, its Launch Quick Process Development Centers, and its Total Solutions philosophy. Tecomet manages every detail of the product launch cycle, a hands-on approach that allows them to better serve their orthopedic customers. Thank you, Tecomet, for sponsoring our webinar today. I'd also like to share a few words about our speaker, Dale Tempko. Dale Tempko is a medical device veteran and consultant specializing in product development, operations, quality, supply chain, M&A, and finance. He has expertise in product development, low-cost sourcing, design transfer, DFM, special process validation, additive manufacturing, failure analysis, and cost accounting. Dale spent 15 years at Medtronic Spinal and Biologics, and during those 15 years, he was the director of the Medtronic Spinal R&D Center in Beijing, and also held the positions of an engineering program manager in R&D and senior engineering manager in manufacturing operations. Finally, a few quick housekeeping items before our presentation. Today, Dale will be speaking for about 35 to 40 minutes. We want to make this experience interactive for you. So at the bottom of your screen, you'll see a Q&A box. Please feel free to post a question as the presentation is taking place. We'll hold a Q&A at the midway point of our presentation, and then we'll hold a second Q&A at the end. So please have your questions ready. Additionally, today's recording will be available on demand from the Bone Zone website, and we will email you a link once it is posted. Dale, thank you for joining us today and for sharing your DFX expertise.
Thanks, Carolyn, and thanks to Tecomet for sponsoring this webinar. It's great that value sharing knowledge in our industry. My son is an engineer working in the medical device industry, and I tell him, you can learn by making your own mistakes, or you can learn from the mistakes of others. During my 40+ years of working, I've made plenty of mistakes, and I've seen a lot of mistakes. The development of DFX is rooted in DFM methodology. It resulted from years of experience, years of making mistakes and seeing mistakes. So we're going to start out and look at a little bit of the evolution. Ooh. What happened here? At the evolution of DFX. It started back in the 1960s and 70s, but really became popular in the 1980s. Boothroyd and Dewhurst were a couple of professors that developed some analytical techniques. And these techniques were really looking at manufacturing and assembly. And I remember going to some track, and it was some pretty good stuff, but really pretty basic. And it was things the same size fasteners. If you're doing an assembly, you shouldn't mix different diameter screws, different thread types, different drive types. It's easier for the operator. They also push things like when you get a part out of a bin, it should be very obvious how the part is assembled into the assembly. So all this seemed like pretty common stuff to me even back then. But as I look back now, it really pointed to an underlying issue, and that was most of product development engineers were focusing primarily on their design and really consideration things outside of the design, like assembly. Early in the 1980s, I was a welding engineer at John Deere. We made combines at the factory where this factory had 6,000 people and about 100 acres under building. I rode around on a little bicycle because the place was so big. They even have traffic lights inside the buildings. And combines are cool machines. I mean, they have heavy weldments and collection of things turning and shaking and rattling and elevating. But they're not cars. They're not automobiles. But that didn't stop the quality department from wanting a perfect body fit. You know, I can still hear it now. That new welding engineer out here, and we'd be in final inspection looking up at this combine and the panels are mismatched. And it was a real struggle. It was about this time that GM launched the Pontiac Fiero. This was a mid-engine sports car. It was sold from about 84 to 88. To me, as an engineer, this thing was a marvel. You talk about DFM. So this thing had a unibody frame and chassis. And on this frame and chassis, there were pads, and they would mill and drill these pads in one machine, in one operation. So when they bolted all the body panels on, it would fit perfectly. And this was revolutionary. I'm like, this has got to be the greatest thing. There was only one little problem. GM lost $2,000 on every car they sold. So now we look at the 1990s. In the 1990s, we saw TQM take off. You know, there was a lot of the kind of the throw it over the wall mentality back then. You know, hey, I'm a design engineer. You guys make it. I design it. You make it. Not my problem. So TQM kind of said everybody needed to be responsible for the product's quality and for quality. Everybody. And in my opinion is when everybody's responsible, nobody's responsible. And about this time, I was working for ABB. It was a large company as a product development engineer. And we were making big circuit breakers. Some of these had 3,000 parts and 14 levels of the bill of material. Kind of puts our products in perspective. So mine was in design and bring it over to the US. Every part of the German design was amazingly engineered. So if you look at this thing, just imagine a metal box with a bunch of thin metal plates in it. The German engineers had taken every plate and every piece and designed it exactly based on the loads this device would see. So there would be plates that would be 2.8 millimeters, the one couple of millimeters or a couple centimeters away, maybe 2.6. This one may be 3.5. This one's 4.5. This one's 4. And everything was designed just perfectly. But that was not for the US market. We didn't have the volumes. They were building for a global market. So our team took it and we designed it to be all from the same plate. That way we could take one sheet, cut all the parts out of one sheet and be done. I was doing a design review over there in Germany and I could see the German engineers just cringing. What are you doing? This is not engineering work. Okay. About that time, the chief engineer walked in and he kind of glanced around and he saw what we were proposing and he said, support these guys 100%. It still points to the fact that even the best engineering solution, the optimized for the actual engineering load, isn't always the best for the company. I entered the orthopedic industry in the early 2000s and wow, was it different. Everything was about speed to market. There's very little regard for product cost or for project cost. It should get the products out there. And successful products made crazy amounts of money. Mediocre products just existed, and even poor products were just kind of ignored and just say, hey, okay, it didn't work out very well. We spent a lot of money, but let's go on to the next one. So at this time, product development, again, we're still focusing on the product, but doing it very fast. And then 2010s, we saw a shift, especially at the big companies. A shift in three areas. They were compliance, compliance, and compliance. Okay. And we know there's a difference between product quality and compliance quality. And there was a huge emphasis on compliance quality. We lived through threats of audit findings, warning letters, consent decrees. You have to around the building like a crime scene. And so there's a huge shift, and we saw a lot of product development resources now being focused on compliance. So we're trying to do things fast. We're trying to do DFM to some extent, but we're also focusing on compliance. So now here we are in the 2020s. Hard to believe, time goes by so quick. Earlier this year, Medtronic had a recall on an insulin pump. The recall was a failure of a pump retainer. The ring would break if the pump was dropped or banged against a hard surface. And for years, Medtronic had spent a lot of resources on what they called DRM, designed for reliability. You can search the internet, and you can find papers that were published by them on DRM. Some are very involved methodologies and some crazy complex mathematical models, some using Monte Carlo simulations. And there was a lot of training, while I was there on DRM and pushing engineers to become black belts and master black belts in DRM. But I wonder, with all this emphasis on DRM, how this could have happened to these insulin pumps. And to kind of show you how important it is, the day after the announcement, Medtronic's market cap fell $4 billion a recall, not million, $4 billion. That's how the street reacted to these quality problems, or this design problem that resulted in this recall. So now we're going to take a look at a classic approach for design for manufacturability. In business school, I was taught a successful product meets a market need at a price the market is willing to pay at a time when the market wants it. So if we're going to develop successful products, let's take a look at the design process and how DFM and DFX fit in. So first, we start off with voice of the customer. And voice of the customer can be a little bit tricky. A surgeon may say, hey, this needs to be stronger. It needs to be stronger than what I'm using or from your competitor. But what does stronger mean? Stronger could mean it needs to be stiffer. It doesn't feel like it's flexing too much. And to an engineer, we know the only way to change that is change the modulus elasticity or the moment of inertia, right? Change the cross section or change the material. That's the only way to make something stiffer. Or maybe they say, hey, when I use this instrument from your competitor or your old product, it's starting to bend. So I need to increase the yield strength. Or maybe they've actually broken some and I need to increase the ultimate tensile strength. So communicating and understanding what the customer is really saying is really critical. The next step is taking user needs, taking the voice of the customer and translating them into user needs and design inputs. And some people really have a difficult time doing this. But if we just take a little very, very simple example, it basically says, the voice of the customer says, hey, my instruments need to be safe. Okay, I'm doing surgical instruments, reusable, they need to be safe. Well, what does that mean? It's like they must be sterile and reusable. Okay, so if they need to be sterile, I'm going to put them in an autoclave. That's a user need. And then the design input is I need to make these from a material that can hold up to multiple autoclave cycles. And eventually the design output is I'm going to make it out of 17.4, some stainless steel I know meets those requirements. Again, that one's very simple, but all of the voice of the customer can be translated into user needs and design inputs and eventually design outputs, kind of following that train of thought. Um, in some cases, though, it's a little bit more complicated. In almost all cases, it's more complicated because it says, oh, in order to be safe, I have to be able to clean it. It's a reusable instrument. I have to clean it. Does that mean I can clean it with disassembly, or maybe I can't? I shouldn't disassemble it. And then maybe there's a need for no sharp edges on an instrument. Okay, so no sharp edges. I know the surgeon doesn't want to cut his gloves, or maybe there's other reasons they have no sharp edges because they don't want to damage adjoining tissue. So they kind of get a little bit intertwined, but again, you lay it all out, you can kind of trace them all back. And then there's other voice of the customer driving design inputs, and that's like misuse. So we know what use is, but we got to think also about misuse. And we also need to think a little bit about off-label use. I was involved in a conversation not too long ago about a product that was very low risk. And we were going through the DFEMA and looking at a few things, and comments were made, well, we're glad we're not looking at off-label use. I said, what do you mean? It says, well, off-label use, they're using this and blah, blah, blah. I can't go into the details, but it's extremely high risk. And some team members, I said, well, how could you ignore that? They said, well, team members were digging their heels in and saying, well, we don't consider off-label use. You know, absolutely shouldn't be considered. Even though the off-label use was common, they knew it happened, it was documented. They'd even put it in their considerations for the new product, and they knew that product failure could result in a patient death. And we're going to come back to this a little bit more later. So in the design phase, we basically look at different alternatives, right? We're taking all these inputs, we're coming in and looking at different alternatives, and it's at this point where traditional design for manufacturability should be taken into consideration. And traditionally, it's been manufacturing, and it has input into that point. So when the design outputs are, when the design is somewhat chilled, that they can still make changes, right? So during the design phase, it's really critical. And what you hope to do is you come up with the best design. But what is the best design? So the best design that's a really good question. So we're going to come back and visit that one a little bit later too. Then we kind of go into the design outputs phase. Design outputs is basically making drawings, specifications, models, those types of things. It's basically, I've got all these designs, I may have some sketches, some prototypes, I got to make all the drawings. And then we go into a stage that's design verival, design verification, design validation. And these tend to be confusing to a lot of people, okay? But if you think about it, I'm going to come over here and point and say design verification looks at design outputs and design inputs. It's basically, do all my design outputs cover all my design inputs? And design validation basically looks at user needs. And I'm actually going to read directly from the FDA's requirements for design verival. According to 21 CFR 820 section 30, it says confirmation by, this is design verification. Design verification is confirmation by examination and provision of objective evidence that the outputs meet input requirements. So verification, inputs and outputs. And then validation is the establishment by the objective evidence that specifications conform with user needs and intended uses. So design validation is basically saying, looking at your user needs. In some guidance, the FDA basically says design verification answers the question, did I make the design correctly? Where design validation answers the question, did I make the correct design? And this is going to be interesting too in the future. And then we go into a phase called design transfer. And that's basically taking all the engineering product specifications and turning them into specifications. And this has been termed different things, design transfer, PPAP, but it's basically, this is where you have to look at special process validations, assembly validations, test methods, inspection, qualification, equipment qualification, all those types of things. So that's a traditional approach to design for manufacturability and where it should happen. Now we're going to come and we're going to take a look at an example. And this example has to do with parametric modeling. So engineers are still, like we said, being pushed to do things very, very quickly. And parametric modeling can save them time. So for people that aren't familiar, the big software packages all have this capability. And it's a way to make your model variable. So in this very simple example, we have a part that has a height, a width, and a radius. And we have 5 different heights, 8, 9, 10, 11, and 12 millimeters. We have 2 different widths, 18 and 20. Again, this is overly simplified. Many of our products in the orthopedic industry, there may be 6 variables or 6 dimensions that are driving 3 or 4 things that are variable. But you'll get the point here. So the engineer decides, hey, I can use parametric modeling for this. I'm going to locate the center of this radius at 1 height below the part and right in the center, so the width over 2. So very quickly, he can create the model that's dynamic that creates all these 10 different designs. But this literally can cause havoc for manufacturing. We're going to take a look at that. So let me jump over here. The result is, this is what it looks like. Every one of these radiuses is different. Every one of them, okay? And so what difference does this make? Well, if this was a PEEK or a titanium part, I could be in here, I'd have to profile mill this or sculpture mill it. I could sculpture mill it with one tool, right? But it's inefficient, takes a long time, drives the cost up. Or I could profile mill it, but I have to have a special tool to create that radius, and it's going to take 10 different tools. And I could check this part pretty simple with an overlay, depending on the tolerances, but now I got to have 10 different overlays. I got 10 different radiuses. So all this stuff adds up. So you cross your fingers and hope that everybody is doing the right thing, using the right tools and the right inspection methods and the right inspection criteria to get the right parts. But this could have been handled much easier. We could have set a 20 millimeter fixed radius. And if you look at the sketch, this is the scale, you can see there's very little difference in the actual profile of the part between the 20 millimeter fixed radius and the variable radius that was driven by parametric modeling. I actually had worked with a client on a similar application or similar issue, except there were 2 different families of parts, and there were 36, I think, iterations of combinations of variables that drove these radiuses. And I did some work, and this was early on in the design process. We did some work, and I said, I think we can get this down to 3 radiuses. I can buy 3 form tools, right? And I can cut this very quick. It was a PEEK part. And once I showed the design engineer, who had been in the industry actually for quite some time, he'd probably been doing design work for 20 years, he saw what he had done. And he came back a day later and said, I got them all to 1 radius. So this saved a huge amount of time, saved costs, saved, inspection time, all this kind of thing. And again, this is a classic example of traditional design for manufacturability, but it also shows this underlying issue that originally the engineer is focusing on the design, okay? Very narrow, only on the design. Of course, we want to have, manufacturing input, hopefully early in the stage, so we can focus on other things, but decide the design. So we're going to pause here for a second, and if there's any questions.
Dale.
Yeah.
Does 3D printing eliminate any issues from using parametric modeling?
So parametric modeling, or 3D printing, of course, you don't have to worry about tooling, right? But if you're machining afterwards and you have to locate the part, it's possible that, especially if you have tight tolerances, that you have to have different fixtures for all these things. I learned a long time ago from an old tool maker. He said, when in doubt, make it stout out of something you know about. And even on 3D printing today, there's a lot of things we don't know about, okay? So I think in general, yes, that, there were a lot lot of advances in, part qualification and things like that are advancing, but there's still some risks. So be very careful when you're using parametric modeling, and if you want to 3D print the part, that you really understand downstream what the effects of all this parametric modeling is. Any questions, Carolyn?
I think we are going to move on now, and will everybody please form some questions, and we'll answer some more at the end.
Okay, great, thanks.
Thanks.
All right, so moving along here. So we're going to talk a little bit here now about DFX and how it evolved from DFM, all right? So the intent of DFX is to develop products that make the business successful, okay? And remember the Fiero? You know, the car that I thought great for manufacturability. Holy cow, and great for quality. At that time, if you were purchasing cars in the 70s and 80s, the US industry suffered from body fit and things like that. And in almost all aspects of Fiero met all the market needs, right? It was pretty popular, but at a loss of $2,000 per car, it saw an early death. And you got to remember, at this point in time, this car cost between $8,000 and $10,000. This is a huge loss, right? So what happened there? It's pretty obvious that, yes, the design and the car met voice of the customer, user needs, all that. It also had great DFM, right? But you still got to make money. It missed a business need. The business need was, I got to make money on what I sell. I can't do this forever. So we're going to take a look at a few examples now. So DFX is kind of a map that leads to successful products. It's not a path. It's not a map that shows you the way. But what it does allow you to do is, at any point in time, you can look and determine if you're on the wrong road, heading the wrong direction. So I wonder at GM, when they figured out that, hey, this Fiero is a cool car, everybody likes it, but we can't really continue to sell it. My guess it was long after there was any chance to do anything about it. So let's take a look at a couple examples here. So, one of the things we always have to do, we should do at least, is design out should be traceable to user needs or business needs. So if we take an example of, say, an instrument with a silicone handle, okay? And the silicone handle happens to be blue. And I go back and I look at I'm trying to do this. Hey, I heard this guy Dale say I should be able to trace this back. I trace it back. I don't see a design input that says handle needs to be blue. I don't see a user need that says it needs to be blue. And I don't think my surgeon cares whether the handle is blue or not. And I actually don't think they care if it's the purpley pink color at Nuvasive. They don't really care, but somebody cared. And most likely it was marketing. And marketing says, for our brand identity, we want to have the handles to be purpley pink, or for a different one, we want them to be blue. So where did we capture that? And typically it's not captured, right? Simple example, I have a design output. I can't design it. I can't trace it back to a user need, but I can trace it back to a business need. Let's look at another one here. So let's say a design output on an instrument has this special black, low reflective coating, okay? And it's called out in the drawing. Hey, this is a requirement. And this was a result of a product development engineer that was really impressed by a small startup that had developed this coating. The coating had many benefits, right? Low friction, all this stuff. It's the latest and greatest thing. One of the benefits was it was non-reflective. And this engineer recalled talking to a surgeon and saying, hey, I don't want my instruments to be shiny. The lights in the OR are too bright, or they're bright, and they shouldn't reflect back. It's hard to see if things are looking like a mirror. So the engineer put this coating on every instrument in the set, even the ones that didn't have to have none, because it looked cool. The marketing thought it looked cool. The engineer thought it looked cool. I mean, this is going to be the latest and great. I'm going to have this is going to be a great product. What was the result? Well, the instrument sets were a whole lot more expensive than what they were supposed to be. Okay. So a lot of them were multi-piece construction, not single-piece construction. So there were a lot of parts. The supplier saw an opportunity to make a lot of money, so he's charging them for every part. Finance made them cut their budget because they were going to spend too much money on instruments. Additionally, the launch was delayed. Why? The startup supplier wasn't on their ASL, so they had to go through a big long process of provisional and blah blah blah, get them on the ASL. The process needed to go through full validation. The supplier had limited capacity because they were just a startup, and so they couldn't handle the volume that was needed. And then the end result was the launch fell short of revenue projections, both on when it was going to start and what the sales were going to be and what the resulting revenue or profit was going to be. So did the special black coating meet the user need? Yes. But what happened? Just like the Fiero, it conflicted with a business need, right? The user need was not shiny. It wasn't, I need to have a black non-reflective coating. Maybe it could have used just a simple glass bead and passivate. That would have provided the same type of non-reflective coating. So a review of design outputs and user and business needs during a design verification and design validation would have brought this to the issue, and then it would have been a much better product. So we talked about design validation. Did I make the correct design? Right? That's what the FDA says. Now I'm going to twist that a little bit and say, well, based on what? Based on user needs and business needs. So what's the best design? We talked about that earlier too. What's the best design? The best design is one that meets user needs and business needs, meets all these needs. So we've looked at a few examples here, very simple examples, and we're going to look at where these business needs come from. And they can come from a lot of places. They can come from virtually any function within the business. Of course, we have user needs coming from our executive leadership. Our CEO is friends with this KOL. He wants these features. All right. They start pushing you. Oh, hey, I want to make sure you include this kind of stuff. Of course, marketing, that's kind of their job. Portfolio management, what I mean by that is we are now seeing cross-business unit drivers of business needs that eventually go into design outputs. So we see things like, it's called different things, procedural solutions, surgical synergy, stuff like that, where we're going to sell them not only implants, but biologics and possibly, navigated and robotics. So we've seen instruments, of course, that once they need to be navigated, they have crazy tight tolerances. These crazy tight tolerances can really drive the cost of an instrument up. So where'd that design input come from? If I was just doing a non-navigated procedure, I would need those tight tolerances. So that really came from a business need that said, I need to navigate, that said, now I have a new voice of the customer, and user needs that says, if I'm going to navigate it, I need to have these tolerances. So you can see how things kind of jump around a little bit. And of course, legal, our industry is full of IP. And there's many times we'd like to use this design, but it's already patented by somebody. So in our design phase, when we're looking at alternatives, some alternatives are not, we can't use them, right? Somebody's already got it patented. And of course, we already looked at finance. Finance, of course, controls the money. They may have targets for product cost, gross margin, project cost, all these types of things. I threw sales in here too. This is one that's not always obvious. And how can sales drive design inputs? Well, our industry has a lot of old products. And a lot of the big companies have very difficult time obsoleting old products because we got a few key surgeons using these products because they like a feature they have. And we continue to, the cost of maintaining these old products because of those few features. So we really should be looking at those features when we're looking at design inputs, even though it may not be a design input or requirement from the current approach, but maybe we can add a few instruments or sizes or something to eliminate those old products. And of course, operations, we know the traditional things there about manufacturing, machining, process validations, all those things that can affect product cost and timelines. And even distribution, now we're seeing if we're in a loan bottle or stuff like that, we have weight limits and things like that. Kind of ran out of room, but I left off probably a little bit on purpose, quality and regulatory, but they can also have inputs or requirements that affect the inputs. So let's move on here. So who's responsible for all of this? And it certainly looks like there's an awful lot of people that need to be involved. And I'll tell you today that a lot of these people are already involved. Okay, everybody has a little piece of the puzzle, a little piece of the map that they're trying to put together. Because I know I talked to my buddy in sales or distribution, or my buddy over here in operation, and so it's kind of like you're trying to find your way in today's approach with a map that's tore up into a bunch of little pieces, and different people have different pieces of the map, and you're trying to figure out how to get from point A to point B. So, product development engineer may say, well, this is the best way to go. And then the marketing guy says, no, this is a better way to go. And then PMO jumps in and says, no, both of you guys are wrong because those are those laws. So remember, DFX doesn't necessarily be able to tell you which way is right, but it can tell you if you're on the wrong path, and it can tell you what's important. So who's responsible for collecting all this stuff? And that's a good question. The short answer is somebody. Somebody needs to do it. Anybody. Somebody needs to do it. Could be PMO, could be marketing, could be the team, could be the product development engineer. Whether it's formal, informal, you need to be looking at all these drivers that affect your design inputs. But we'd also need to look at a prioritization, especially when for both user needs and business needs, because a lot of times you get into a give and take, situation. So, it could be what's most critical, project cost or when the revenue will start. So maybe I can spend a little more money on my project and I can start selling it quicker. Or gross margin versus product features. If I add all these features, my cost is going to go up and I'm going to deteriorate my gross margin. Or maybe things like IP risk. Maybe I am a startup and I'm more willing to take some IP risk than some of the bigger companies. So our leadership, our executive management would give us those directions, but it's been my experience that they don't know the details. So if you ask them, what should I do? They don't really have the answers because they don't really know the intimacy of what's going on. So it's really up to the project team. The project team really needs to step up and say, look, I have three options. I can do A, B, or C, and then bring that to your steering committees or whatever checkpoints you have along your design and say, which way do you want me to go? I can launch this a little earlier. I need to spend some more money. I can take these features out and I can save time. I can launch earlier. So all these things need to be brought up to them. I really think that's the best solution, is to have people on the team that understand it, look at these during phase reviews, and do the design validation looking at business needs. So we're going to move on now to look at a couple things that may look a little surprising. We touched on these earlier. Remember the Medtronic insulin pump recall? The one that resulted in the $4 billion drop in market cap? Well, I'll tell you, I have no knowledge of what actually happened there. I have no inside information, but this sure makes a good example. I can imagine that an engineer would say, dropping or banging an insulin pump up against a hard surface is misuse. And, I'm sitting here wondering, with all this effort, with all the emphasis they had on reliability and manufacturability, what was in the DFEMA for that particular feature of the pump? Obviously, it was missed. And I wouldn't want to be the team that was working on the DFEMA for that pump. But again, we're kind of talking about misuse. So I want to give you a little example here. Let's look at cell phones. I still blame that frog. What frog? The frog that was in my pool skimmer basket. The one that scared me when I lurched back, my phone came out of my pocket and straight to the deep end. And no amount of rice or desiccant or even 8 hours in a vac chamber could revive the screen. And certainly that was misuse, right? Look, what the cell phone companies have done is most of the new phones are water resistant. And what did they do? They looked at that misuse, right? And they knew that was irritating their customers, but they didn't want to make a design change and add cost and all this stuff just because of that. What they did is they used this to their advantage. By the nature of them sealing the battery now in the phone, I have enough components. Now I have a water resistant phone, right? I can drop it in water in a bucket, wherever, and fish it out and it's still going to work. But what can I do? I can't change the battery. So yeah, maybe in the past they were driving some incremental sales based on people that dropped their phone in water and it no longer works, so they buy a new phone. Maybe it was there to buy a different model. But now everybody's phone is completely sealed, and eventually, like my phone, it's a year old, I can already tell the battery's starting to deteriorate. Where before I would just open it up and get me a new battery and stick it in there and say, wow, it's just right back to normal. So now they've driven a lot of additional business by looking at misuse. So what did they do? They looked at misuse and solved what was reasonable, okay? You got to use reason when you're looking at misuse. If I buy a Harbor Freight 3/8 drive ratchet and put a 4-foot breaker bar on it, that may be a little unreasonable to say it shouldn't have failed. Let's talk a second about off-label use. And I can imagine some people are saying, this guy is totally crazy considering off-label use for design inputs. And I'm sure it's very sensitive to people, especially illegal. But we know that in our industry, there are people using products off-label. And some of the off-label use is high risk. One test for this type of discussion, when you're having these discussions, it kind of follows these lines of, well, what would you say? What would happen if you were in a court and you had to defend your company? I could hear it now. Mr. Temko, were you aware of the rampant off-label use of your company's product? Yeah. Temko, know that the failure of your product would lead to death if it functioned correctly? Yes. Is it correct that you knew the risk and did nothing to prevent failure of your company's? So you see how this line of reasoning goes, this argument. But I don't really, and for anybody that's been in depositions or in court, this is no fun, right? And it's no fun being put on the spot like that, especially for an engineer. We don't think like this. So like I said, I don't really like this line of reasoning. It doesn't always bring you to the right conclusions. It's kind of like the threat of audit findings and stuff like that. So what should we do? We should do what's right, okay? Not because of fear of an audit finding or court cases, but because it's the right thing to do. And how do we know what's the right thing to do? You answer one question. Would I want this product used on someone I really care about? Your daughter, your granddaughter, your mother, your sister, your brother. Whether it's on label or off label, if there's any hesitation to say yes, you're probably not doing the right thing. So I know it's a little bit controversial or unnerving maybe to talk about off-label uses that actually would drive design inputs, but it's something we should actually consider. So where should all this stuff go? All right, now we got before we're being driven from VOC, right? And those are going to design inputs. But now we got other business needs driving design inputs. So I kind of favor putting it in the DFEMA, but it's really up to your business. All the product features should be covered in the DFEMA. So all those features should be driven by design inputs and user needs So it's a perfect place to put it, but it can be a little overwhelming because, again, you have a lot of interrelationships and stuff like that, and a lot of features. And then you also have a lot of different failure modes. So I'm going to make just a quick comment on DFEMAs, and DFEMAs should address how the design can fail, right? It's a design failure mode effects analysis. It's the failure of the design. So making the product from the wrong material in manufacturing is not a design failure. I see this on DFEMAs all the time. People blur the lines between a PFEMA and a DFEMA. No, the DFEMA says I designed the product from the wrong material. Okay. Remember the insulin pump? You know, I bet you that there's a different impact resistant material in there now. That was a design failure, not a, okay, that was a design failure. Too often, DFEMAs are being done just to get a checkbox for compliance reasons. But there's reasons that the regulators require risk management on products like that. Do a good job, it pays off. The issue of using a DFEMA, however, is you're mixing, business needs in with what would eventually would be a DHF document for compliance. So some people, that really makes them uncomfortable. I don't think it's an issue myself. The FDA doesn't really care about your business. It doesn't care whether you make money or lose money or launch successful products. They don't care. They just care about being compliant with the law and follow your procedures. Are your products safe and effective? They don't care if it's successful or not. So I don't think it would really be an issue if the business needs were clearly identified. But if mixing it is a problem, just do it in a separate document. Okay. So here's some of the key points. Start early. For DFX, DFM, you have to do it when you're looking at design inputs, when design inputs are being developed. Include cross-functional expertise, nothing more critical. We looked at all the different areas that can have effects on design inputs. Define priority of customer needs and business needs. So there's direction and you understand what alternatives are picked and why you picked them. Trace output back to needs. If you can't trace a design output back to the user need or a business need, then why is it there? Shouldn't be there. Use design val for business needs as well as customer needs. And consider misuse and off-label use. We just need to do the right thing. So now we have time for a few more questions. Carolyn, did we get any other questions come in?
Yes. So, Dale, in your opinion, what is the best way to obtain voice of customer and user needs if you are not in direct contact with the surgeons, but are designing to sell to various OEMs like Medtronic and DePuy Synthes? This person says, experience has shown that it is challenging to find the right person at the OEM who can truly provide this input to represent the position of the entire OEM.
So it really is, it's a difficult thing to do correctly and comprehensively. So, this is why it's important to document and trace back where these things came from. Just like the example I gave on the VOC about it being strong. So anytime you're doing VOC, there should be a team of people, including marketing and engineers. Okay, so they can get the information and get it translated correctly, and then go back and then have a document that puts them all together and say, which voice of the customer elements am I actually going to use for drive user needs? So it isn't an easy thing to do, but it is critical, okay?
Another question.
Any other questions?
Yes. How do we know that our DFEMA covers all the potential failure modes from all of the uses?
So that's kind of a difficult, it's kind of difficult, okay? I think there's a lot of emphasis right now on diversity and things in our workplace, right? That we get better solutions by having a function of different types of people. But there's one area that I would say really shouldn't be overlooked, and that's people with a lot of experience. I was involved in a case with a product and went to visit her where in the use of this product, a person was killed, okay? And when you go through that, and you become very sensitive. And in this particular case, the product didn't fail, but we could have put a few little design changes that would have prevented this accident from happening. So when you do that, it changes your mind, changes how you look at things. That's why you hear me talk passionately about doing DFEMAs, about saying, hey, you really need to put time in it and not make it just a checkbox. So we spend a lot of money launching new products, lots of money. And whether you have an internal independent review of your DFEMA saying, please look at this and see if there's anything you can think of that we didn't do, or hire some old guy like me that'd been around the block and, like I said, made many mistakes and seen a lot of stuff fail, get some independent review. Don't turn it into a checkbox. Okay?
So this question is assuming that the team, didn't follow DFX during the design phase. If a product is already in the design transfer phase or the pilot production phase, how can they make sure DFX implementation is actually taken care of?
It's again, you've already created the map and you're already where somebody decided where you're going to be. Okay. So it's extremely difficult, and if there's any message that we can get to the big OEMs or anybody that has design responsibility, is you have to do this stuff up front. You have to do it before your design is frozen. And you really should just do it when the design is starting to get chilled a little bit. When you start solidifying and say, this is the direction I think I want to go, at that point, it's almost too late. You really need the input up front. I can give like an example. It could be, hey, this black coating, we can't use it. Okay, it's too expensive. Take it out. But if you have that conversation up front before you specify, you can say, well, let's early in the process work with this new startup supplier and say, look, we're going to do it, but we can't afford to give you this money, right? We can't afford to let you, to have the product the way or the pricing you're giving us. So you could have had that conversation up front. They could have had the conversation about expanding capacity. They could have said, hey, this does really look good, and we really think we can leverage it if we can get it at the right price point. So having those conversations up front is absolutely the key. Once you're downstream, especially after product testing is done, the design verification product testing, with whatever it happens to be, whatever the product is, there's almost no chance people are going to go back and test. So after that fact, it's almost impossible, and it's possible oftentimes to do design changes at that point.
Throughout your presentation, you suggested multiple times that the project team bring the options up the ladder. Has that been your position? Is that what you've seen in the past, or your experience?
I really haven't seen people, use this approach driving from design input perspective, from a design perspective, to say all these things in the business that's affecting my project. Typically what happens is those business needs are dealt in a separate process, the commercialization or whatever. So your PMO office or your PMO people may say, hey, you got design stuff, it goes into DHF. We have commercial stuff. We manage both of them, but we keep them separate. So a lot of these things eventually come to light late. Okay. Again, we talked about the timing. So they kind of get mixed, or they don't get put together. So you have one story. So no, I haven't seen, it combined, but I've seen it done separately,
how do you approach DFX when you have design or product development engineers who are set on avoiding any changes that were not designed here and push for a design that is less manufacturable, more costly, simply because that was their initial design?
You know, this is a business dynamic. This is the old kind of throw it over the wall mentality. And the solution to that is defining that says you have business needs. Your design has to meet the business needs as well as your customer needs. You know, and give them the example. Give them some of the examples I even talked about, like the Fiero. It says you think business needs, right? So now I have a design that's difficult to manufacture. It's going to drive your costs up. It's going to extend lead time for launch, you know, and appeal to the guy that the product development engineers and say, look, you know, all these things are going to be creating headwinds against you and your project team. And, you know, there's better options. You know, things always take longer than what you think, right? And what you plan. So if you add these things and you say, I'm going to dig my heels in on this design, knowing that, yeah, you know, I'm going to have to create hard gauges because you got datums I can't find out what it's now, right? Or all these things that can affect things, you know. It says, oh, it's going to take me twice as long to manufacture this now. So when you go to launch and you give the supplier, your contract manufacturer, your internal manufacturing people, okay, here now I need, you know, for some of the big companies, it could be I need 20,000 implants. Well, yeah, if you wouldn't have changed these things, I could have cycled X, and now I got a cycle time of X times 2. I could have launched your product in, you know, half the amount of manufacturing time. All right, so that's the appeal is you want to do your job right, you know, that includes the whole project and making the project successful. Because what do we want to do at the end? We want to launch projects that make the business successful, right? So driving revenue and getting that stuff started is key. Anything else?
Should processes be included in the DFEMA or strictly be contained in the PFEMA?
Oh my gosh, this must be somebody I know because I have very, very strong opinions about this, and I know there's a huge mix in the market, in the industry. So in my opinion, the DFEMA is clearly, in my mind, a design failure. I designed the product wrong. No process stuff. And in the process, in a PFEMA, there should be no design issues. You know, a PFEMA should concentrate only on making the part to print. Is my part conforming to the specifications? Yes or no? I don't care about VOC, design inputs, intent. I don't care about all that. I have a instruction right there. It says, make this. You know, the drawing, and it says, I'm either going to make it conforming or I'm not. What are the risks of me making it non-conforming? The thing should be covered in your PFEMA. Again, that's one of my, so I could probably do a whole webinar just on, you know, and now we have use FEMAs, right? We have UFEMAs for looking at how products are used and misused. So all of those really have should have very specific and focused objectives of what you're trying to cover and what risks you're trying to. So again, sorry for getting on my soapbox, but that's what I'm a little bit passionate about.
So Dale, the last comment was just a thank you to you in the comment, the Q&A section. So I think that we will wrap it up there.
Okay, great. If you have any other questions, you know, there's my email address. It's on the in the PowerPoint, and that'll be put on the website. I want to say thanks for everybody. Hope you found this a little bit informative and maybe even a little bit entertaining from an old guy.
Well, thank you, Dale. Thank you for sharing your expertise. Thank you to TECOMET for sponsoring our webinar. And thank you to those who attended. I hope you found that the information presented today was valuable to you. One of my great takeaways from today was that DFX just addresses a much wider range of benefits for device companies and certainly provides a structured approach to your new product development. If you are seeking more content on this topic, I would direct you to bonezonepub.com. Dale wrote an article on DFX for BoneZone a few years ago. The title was Unlock DFM Benefits, a guide for product development leadership. And a lot of the content that he pulled from his presentation today is also in that article. Finally, as a reminder, a recording of the webinar will be available on demand on the BoneZone website, and we will email you once that is live and available. So thank you all for watching. Stay well.